Hello everyone, welcome to my channel. So in this video we'll be learning about recursion in C. So first of all, what is recursion? Now as the name suggests, it is something which is like reoccurring. So basically when a function is called within the same function, or when a function is calling itself, then it is known as recursion. So let's say suppose I have given void function, and in this I have given some statements and performing some kind of calculations, and then here I'm doing the function calling. Again I'm performing some kind of calculations. So basically what is happening is that this function is calling itself within the same function. So this is known as recursion, and the function that calls itself is known as recursive function. Okay, so this is like the basic definition of recursion. Now for example, if I want to write a program on the factorial, let's say I want to write the 5 factorial program with using recursion. So basically first we need to understand what is the logic behind this. So you know that 5 factorial is nothing but 5 into 4 into 3 into 2 and then into 1. So this is what your 5 factorial is. Now the same 5 factorial can be written as 5 into 4 factorial, right? Because this is nothing but 5 into this part is your 4 factorial, right? So the 5 factorial can be written as 5 into 4 factorial. Similarly, the 4 factorial can be written as 4 into 3 factorial. Then this can be written as 3 factorial can be written as 3 into 2 factorial. 2 factorial can be written as 2 into 1 factorial. And 1 factorial is nothing but 1. But again, you can either stop the process over here or you can continue with one more step, that is 1 factorial can be written as 1 into 0 factorial. Now we all know that 1 factorial is 1 and 0 factorial is also 1. Okay, this is what your basic mathematics says. So we can like stop the process at this point also, or we can stop the process over here also. Okay, now this is what happens in your basic factorial part. Now basically what is the logic that you can see over here? The logic is we are doing n into n minus 1 factorial. If you look at each of the steps, what we are doing here is we are doing n into n minus 1 factorial. That is what we are repeating, and it's occurring in each and every step. So this is the logic behind your recursion, this function. But now if you don't give a terminating condition, this will keep on going. Okay, like this will go on to the next step also, that is it will become this part will become 0 into minus 1 factorial. Again this will become minus 1 into minus 2 factorial. So what I mean is that it will keep on going if you don't stop it. Okay, it will continue to go and it will continue to produce till infinite loops if you don't give a ending condition to it or a terminating condition to it. So now here we need to understand what is the terminating condition. So basically now in this program you want to stop it over here at this step. So for that, what you can give the condition as n is equal to 0. Okay, this can be your terminating condition. So that means when the program, that is when the loop is running, and when they check that n is equal to 0, that is when they reach this step, they will understand that n is equal to 0, and this condition which is there, it will be satisfied. So automatically the loop will stop working and will terminate over there, and will not move on to these further steps which are unwanted basically. So that is your terminating condition. So it is very important, that is two things are very important in your recursion. First thing is what is the logic that you are putting behind it, and then second thing is your terminating condition, because if you don't stop it, then it will keep on moving. Also in case of this factorial program, instead of stopping at this point, you can stop in the previous step also, that is at 1 factorial, because it will give you the same answer, right? This last step, that is 1 into 0 factorial, is nothing but 1. So instead of stopping at that part, you can stop at the previous part also. So for that you can give the condition as n, let's say n less than or equal to 1. Okay, so as soon as the compiler checks that n is less than or equal to 1, suppose the compiler will come over here, n value is 1. So this condition is satisfied, n is equal to 1. So as soon as the condition is satisfied, that is the terminating condition is satisfied, your loop will stop over here, it will stop working, and then you will go back. Okay, so basically here the condition will be terminated. So that is your terminating condition. Now since this is recursion, everything is going to repeat or reoccur. So what happens is, as soon as your program is terminated over here at this condition, now we will go back. Okay, now let's say we are terminating at this condition as of now. Okay, so we will terminate it over here. Now we will go back and multiply. This 1 will be multiplied with 2, then this 2 will be multiplied with 3, 3 will be multiplied with 4, and 4 will be multiplied with 5. So this is what happens when you give the return statement. Okay, so when you give return in your recursion, this is what happens, that the last function calling that is done, it will return back to the part where it was first called. Okay, so basically what is happening over here is we are going to that part of the program where the function was first called. So this one was called over here in this 2 part, so we are in this 2 part, so we are returning to that part. So 1 gets multiplied with 2, then 2 gets multiplied with 3, 3 gets multiplied with 4, and 4 with 5, and then you get the final output of your 5 factorial. So this is what happens behind the factorial function when we use it with the recursion. So now let us see some example programs in this. Now this is an example program for your recursion. So first let us see what the output is, and then we'll understand how the output came. So this is what our output is going to be. Now let us see how this output has arrived. Okay, so first of all, if you can see over here, this your void function int n. Okay, this is your basically your function, and then here you can see that same function is being called within itself. Okay, the same function is being called within itself. That is what is known as your recursive function. So this is your recursive function. Now first we will look at the main function, and then we'll try to create stacks, and we'll try to understand how it is happening. So first, this is your main function, right? So in this you can see there is a variable n that is created, and that n variable has been assigned the value 2, and then we are doing the function calling, function of n. Okay, so first let me create a stack. Okay, this will be your stack, and in this stack we will create racks, or we will create some kind of frames where will the different function calling will take place. So my first frame will be created. Okay, this is my first frame. This is for main function. Okay, so when I come over here, like this is what happens in a stack, right? First you keep the blocks one by one. So like that only we are trying to put the different steps of recursive function. So first I have created you can say a row or a stack for this main function, and in that what you can see is your n is equal to 2 right over here. So what is my n value? My n value is 2 in this particular stack. Now the next step that is taking place over here is the function calling, this function of n. So I'm going to go at this part. So here this function calling, function of n is taking place, and right now my value of n is 2 over here, as you can see, right? The value of n is 2. So I'm going to go at this part, okay, this part, and now I'm going to perform that function calling. So function of int n. Now what is the function value, n value over here? N value is 2, right? Because we are doing function of 2. Okay, we are doing function of 2, right? So my n value is 2. Now I'm going to enter that, okay, with 2 value. Now if I check this condition over here, 2 less than 1. Now is that condition true? No, right? It is false. 2 is not less than 1. So we will directly go to the else part. And in else part you can see we have got 3 statements, that is we need to execute. Okay, so the first thing that I'm going to do here is, as soon as we perform function of 2, the function calling takes place, and I'm going to create one more rack for that function 2. Okay, this is my rack for function 2, and here right now my n value is 2 at present. Okay, my n value is 2. And the first thing that I'm going to do here is, as you can see, there's a print statement. So I'm going to print n value. Okay, n value. And right now, what is my n value? My n value is 2. So as you can see in the output, my 2 is printed in the very first thing. Okay, 2 is getting printed. And what is the next thing that they have given? It is function of n minus 1. Again, a function calling is taking place. Okay, so I'm going to do function of n minus 1. N value right now is 2. In this particular rack, n value is 2. So what is function of 2 minus 1? It is function of 1. So again I'm going to do a function calling with function that is with n value as 1. But you can see here there's one more printf statement over here after the function calling step. So that printf statement we are going to keep it aside because that will be printed in the last. Okay, right now first step that we have to do is function calling, because the 7th step that you can see, which is the function calling, that has to be done first. Only then we will go for the print function. So now we are doing the function calling for 1. So I'll create one more rack for that. So I'm going to write here function of 1. So this I've created for the n value 1. Now I'm going to again follow the same procedure, the same steps that I did for function of 2. First I'll check the n value, that n less than 1 if condition. Now here my n value is 1. Now 1 less than 1, it is a false condition, right? 1 is equal to 1, but it is not less than 1. So we will directly move on to the else part. Okay, in the else part, then we will execute those 3 statements. First thing is we will execute print n. So first let me write the n value. The n value in this particular rack is 1 as of now, because you can see here this is the n value, right? In function n value, that is n parameter, has been assigned value 1. So my n value is 1 over here. I will print n, that is my first command in the statement number 6, and you can see here in the output 1 is being printed, right? Then they have given function of n minus 1, so it will become function of n is 1. 1 minus 1 is 0. Okay, so function of 0. Now again I'm doing a function calling, so again one more rack for function of 0 will be created. Okay, I've created one more rack. Now you can see there's one more step. In the 8th step you have to print n. Again I'm going to put this aside because this will be printed in the last. First I will perform the function calling of 0. So now I'll come to this rack. Now currently my n value is 0, right? Here you can see my n value is 0. Now I will check the condition if n less than 1. So n here right now is 0. Now 0 less than 1, the condition is true. So instead of going to the else block, we will execute the if block, that is the 4th statement. Okay, the 4th statement says return. Now this part can be confusing for a few people, but it is actually very simple. Now by return what you mean, you're going back to that part where the function was first called. Okay, so right now we are in which rack? Right now we are in the rack of function 0. So now we have to return this part. Okay, so we are going to go to that rack where function 0 was first called. So that is the previous rack. Previous rack mein function 0 was first called. Okay, so here when we come, we see that we have one statement that is left to be printed, that is print n statement. And what is the n value in this particular rack? The n value is 1. So 1 is being printed in the output. Now we have a function 0. Now we are in which rack? We are in the rack of function 1. Okay, this function 0 is done, it is printed. Now we are in the rack of function 1. Now we have to return this function 1 also. So we will go back to that location or that place where this function 1 was first called. So it was called in the previous rack, right? You can see here this is your function 1 where it was first called. So we are going back to that rack, and again you have one printf statement which is left over to be printed. So that you are going to print. So what is the n value currently in this rack? The n value is 2 in this rack. So 2 will be printed in the output. Then again you're going to go back to that place where function of 2 was first called. So it was called in the main function. Now if I look in the main function, there's nothing more to be printed. Okay, there's nothing more to be executed or printed. So I'll just come out of my program. So this becomes my output, that is 2 1 1 2. So basically first I was going above, like how you go in a stack, right? When you have a when you have to put a stack, what you do is first you put the lower block, then you put the upper block, like that you keep on going, right? First you put this block, then this block, then this block. But when you want to remove the stack, what do? You don't remove the first block first, right? You remove the upper one first. Okay, so that is what is happening in the return statement. You will go back to that step where the function was first being called. So for 3, I am going to the second step. For second, I will be going to the first step and I'll execute the statements that are being left over. So that is how I get this output. So this is what happens in a recursive function. Now let us see one more example on this. So this is our next example on recursion. So this time we won't go by the stack method, we'll try to do it directly. So first let me run this program. Now 15 will be the output of this program. Now how are we getting the output as 15 is what we are going to see now. Okay, so the first thing that I'm going to do is look at the main function. Okay, this part is your main function. So first we created a variable a, and that a has been assigned as sum of 5. So we are doing the function calling over here. So first in your main part, the a variable is created. Okay, the main function, the a variable is created, and we have been assigned sum of 5. So sum 5 we are giving over here. Okay, now what I'm doing is I'm doing the function calling. So here, as you can see with this part, sum of int x. So when I come over here, what is my x value? Here I have given sum of 5, so my x value becomes 5. Now I'm going to check the if condition. Okay, this condition I'm going to check with x value as 5. Now is 5 equal to 1? No, right? It is false. So I'm going to come to the 7th step. The 6th step is the if condition step. I'm going to skip that step because the condition is not true, because 5 is not equal to 1. So I'm going to come to the 7th step, that is I'm going to perform this s is equal to x plus sum of x minus 1. So what I'm doing over here is I'm doing x. What is x value? X value right now is 5. Okay, the x value is 5. So 5 plus sum of x minus 1, that is 5 minus 1, which is nothing but 4. Okay, so this is what we got here. Now again I have to do a function calling with sum of 4 value. Okay, with the x parameter equal to 4, I'm going to do a function calling once again, and I'm going to check the 5th step, that whether 4 is equal to 1 or not, which is false. 4 is not equal to 1. So again I'm going to come to the 7th step and I'm going to perform that, and I'm going to do the same calculation, that is x plus sum of x minus 1. So right now my x condition, that is x value, is 4. So I'll do 4 plus sum of 4 minus 1, which is nothing but 3. Okay, again I'm going to do the function calling with sum of 3 value. Okay, again I'll check if 3 is equal to 1, the condition is false. I'll come to step 7, and in step 7 I'll do x, which is nothing but 3. Okay, x is 3. 3 plus sum of 3 minus 1, which is nothing but 2. Okay, now I have to do a function calling with x parameter equal to 2, that is sum of 2, and when I do that, I'll check if 2 is equal to 1 or not in the if condition, which is again false. So I'll directly come to the 7th step. I'll do x, which is 2, plus sum of x minus 1, that is 1. Okay, now my x parameter, that is x value, is equal to 1. So again I'll come to this if condition. I'll check if 1 is equal to 1 or not. So that condition is true now. So I'll come to the if block, that is the 6th step. Now I have to return the value of x. Now what is my x value right now? My x value is 1, right? So I'm going to return 1. Okay, I have to return 1 now. Okay, so basically I have to perform this step, that is returning of x. Okay, so now I'm going to return. Return means basically we are going to go to that part of the program where the function was first called. Okay, so that is basically we are going to the previous rack or the previous step. So when I go to the previous step, now right now my x value, this value is 1, sum of 1 value is 1. Okay, so I'm going to perform 2 plus 1, which is nothing but 3. Okay, now I'm going to go to the previous step once again. Okay, basically we are just going back to the previous steps because that is where the functions were first called, from the previous step. So now my sum of two value is nothing but 3. Okay, this is 3 what we got, so this becomes 3 over here. So 3 plus 3 is nothing but 6. Okay, now I've got the value 6. Now I'm going back to the previous step. Now my sum of 3 value will become 6, and now I'm going to perform 4 plus 6, which is nothing but 10. Okay, now I'm again going back to the previous step. Now my sum of 4 value is nothing but 10. That is the previous value that we got is nothing but 10. So I'm going to do 5 plus 10, which is nothing but 15. Okay, so now my latest value, whatever I got, is 15. Now this 15 value, I'll assign it back to sum of 5. And sum of 5, as you can see from the main function, it will go back to the main function. And in the main function, the sum of I value was nothing but it was assigned to the variable a. So that value is nothing but 15. Okay, so now my a value has become 15. So the next step is what? Printing the value of a. So that is what I'm just printing the a value, and a value is 15, and that is what I have got here in the output. So what I'm doing basically in recursive function is that once I call all the functions from top to bottom, then what I do is I just went back to the previous steps. Okay, I went back to the previous steps where the functions were first called, and I'm going to perform the same operations, and that is how I got the final value. Okay, so these were some examples for recursive functions. So if you have any doubts, you can let me know in the comment section below. Thank you for watching, and meet you in my next video.